this video, we will focus on NET. The most common form of network address translation or NET can involve a large private network using a private IP address range. The private addressing scheme works perfectly when clients of the network accessing its own resources, such as a printer. The network router can route traffic without trouble inside the private network. But when clients want to access external resources such as internet, the client should have a public IP address. Here comes NET into play. Network address translation or NAT is a mechanism where a network device, maybe a NET router, assigns a public IP address to a computer or a group of computers inside a private network. The main use of NAT is to limit the number of public IP addresses an organization or a company must use, which may be due to both financial and security purposes. Let's analyze NAT using Wireshark packet tracers. This is the scenario given in the assignment. Figure shows the Wireshark trace collection scenario. Within the home network, the home network router provides NAT service. A packet trace has been captured from a simple web request from a client PC in the home network to www.google.com server. The Wireshark trace collected in home network PC is called NAT home side going forward. Since we are interested in the packets being sent by the NAT router into the ISP, a second trace file has been collected at a PC tapping into the link from the home router into the ISP network. This Wireshark trace is referred as NAT ISP site throughout the video. To answer the first 5 questions, we need to analyze NAT home side Wireshark packet trace. First question is about the IP address of the client. 192.168.1.100 is the client IP. The client actually communicates with several different Google servers to implement safe browsing. The main Google server which serves the Google web page has this IP address. To display only those HTTP messages, we can copy-paste this expression into the Wireshark filter field. When we activate this filter, we can see the HTTP messages that are sent to O received by the main Google server. Now we have to consider the HTTP GET sent from client to Google server at this time. Here is the HTTP GET sent from the client. These are the source and destination IP addresses, and these are the port addresses. Next, we have to consider about the 200 OK HTTP message. Here is the HTTP reply sent at this time. These are the source and destination IP addresses, and these are the port addresses. Before a GET command can be sent to an HTTP server, TCP must first set up a connection using the three-way sync-ACK handshake. To find the sync and ACK segments corresponding to this type, we have to remove the filters. This is the corresponding HTTP GET, the sync and ACK segments. Considering the sync segment, these are the source and destination IPs and these are the port numbers. Considering the ACK segment, these are the source and destination IPs and the port numbers. To answer the next 5 questions, we need to analyze both NAT home side trace and the NAT ISP side trace. Now we need to find the HTTP GET message sent by the client to the server at this time from NAT ISP side trace. To do so, we can paste the same expression which we copied previously into the Wireshark filter field. Here is the same HTTP GET message on NAT ISP side and it was recorded at this time. These are the source and the destination IPs and these are the source and destination ports. When comparing to the answers of the question number 3, we can identify that the source IP has been changed as a result of NAT translation. To answer question 7, we need to compare the fields of HTTP GET IP datagram on both sides. When comparing the HTTP GET message in client side and server side, we can identify that fields such as version, header length, and flags are not changed, but checksum has been changed. This is because the IP source address has been changed and checksum value depends on the source IP. Now let's find the HTTP 200 OK message from NetISP trace. This is the HTTP 200 OK message and it has been received by Google server at this time. These are the source and destination IPs and these are the source and destination ports. When comparing to the HTTP 200 OK message in Net Home side with NetISP side, we can identify that the destination IP address has been changed as a result of net translation. Now we have to locate the TCP three-way handshake sync ACK segments corresponding to this HTTP GET message on the NetISP trace. To find these sync ACK fragments, we have to remove the filter from Wireshark. This is the corresponding HTTP GET, the sync and ACK segments. Considering the sync segment, these are the source and destination IPs and these are the port numbers. When comparing the TCP handshake sync ACK fragments, we can see the source and destination IPs has been changed. Although the client IP is 192.168.1.100 in the home site trace, it has been changed to 71.192.34.104 in ISP site. This is due to net translation. This is the net translation table constructed using the explanation.